All right, this is the first video going over the opener where we're deriving the mean and the standard deviation of a binomial random variable. So the problem starts with what we call Bernoulli trial, which we've talked about. That's just one trial of sort of a binomial situation where we're going to code a failure as a 0 and a success as a 1. And we're just going to call the probability of success P, which we've talked about. And the probability of failure is obviously then 1 minus P, which we're going to just call Q, just to make it a little bit easier to write this stuff. So if X is the outcome of a Bernoulli trial, this right here is the probability model for X. Okay, this is a Bernoulli trial. So it might represent the flip of a coin, it might represent rolling a die and seeing if we get a 3, it might represent doing a blind taste test on somebody and seeing if they prefer Pepsi or Coke. There is some true probability that a person can tell the difference, and that would be P in that case. So we're going to derive what the mean of this Bernoulli random variable is. Really, really simple. That's the expected value, okay, which is also we would call the mean of X. And we know how to do that. We just do 0 times, so this outcome times this probability, which is 1 minus P, or Q. I'm just going to write 1 minus P. That term is going to go away anyway. Plus 1 times P in this case. This term is 0. This term is P. So the mean of this Bernoulli random variable is P. Okay? Now let's find the variance. Okay, and it says variance here, so I'm not going to square root my answer. The variance of X, which is also known as sigma squared of X. Well, how do we find the variance? We take each value, okay, here's the value, minus the mean, which is P. So this would be 0 minus P, and we square that, and we multiply it by the probability. So I'm going to multiply that by Q. Okay? Plus, well, here's the second outcome, 1 minus P squared times P, because that's the probability there. Okay, so let's actually find what this is. 0 minus P quantity squared is just P squared. So this is P squared Q plus, now 1 minus P is the same as Q. Okay, so this is Q squared right here. So this is plus Q squared P. All right, so if we continue to go on here, let's say I'm just going to do some algebra to this expression. I'm going to factor this thing. So I see a P and a Q is common to both terms. So I'm going to factor out a PQ. So I get PQ, and then I get P plus Q. All right, well, P plus Q is equal to 1, if you think about it, because that's the sum of these probabilities. So this thing is equal to 1. So the answer to this, the variance of the Bernoulli random variable, is PQ. Okay? So the mean of this Bernoulli trial is P, and the standard deviation is Q. Or actually, sorry, the variance is Q. If I wanted to find the standard deviation, I would square root that. All right, now, suppose we define a new random variable, which is just going to sum up a bunch of Bernoulli trials. Okay, so if you think about it, if we sum up these Bernoulli trials, since we're calling a success a 1 and a failure a 0, summing up the Bernoulli trials would amount to adding up all the successes, or counting the number of successes. So this is a binomial random variable. So y is actually binomial. That's actually our definition of binomial mathematically. It's the sum of a bunch of Bernoulli trials. Okay, so if we were to find the mean of x plus x plus x plus x, n of those x's, well, think about what we do. The mean of y would just be, well, we take the mean of x, p, and we'd add it up. Well, we'd do this n times. So the mean is n times p, which is something that we have intuitively already talked about. Okay, we talked about it. It's intuitive that the mean of a binomial random variable is just n times p. Okay, it's the expected number of successes in n trials. All right, so now let's find the variance of this binomial random variable. Okay, so we're finding the variance. This is this. Yep, I put the 2 in the wrong place. So we're going to take this thing, we're going to add, not this thing, we're going to add the variances, right? Because we know the variance of one trial, we're doing the variance of the sum of a bunch of trials, they're all independent, and so we know that we add the variances. So the variance would be, okay, here's the variance of one trial, it would be PQ plus PQ plus, we do this, n times. So this gives us NPQ, or NP times 1 minus P. So this would be the variance of a binomial random variable, which means the standard deviation of a binomial random variable would be the square root of NP times 1 minus P. Okay? So, this is just a derivation. It's a proof of these formulas, which you need to know. Okay? You may not need to derive this ever again, but I wanted to show you it, or have you try it, because it does show how adding the variances are really important. So here's what you need to know. If x is binomial with these parameters, n and p, the mean of that is n times p, and the standard deviation is the square root of np times 1 minus p. Those are key formulas that you should write down, and you should know. Okay, we just derived them. Now we're going to use them to do certain things. Okay, so please write those down. If you didn't, if this video wasn't satisfactory in the class time, you can feel free to watch it on your own time.